Hello everyone, you are welcome back again. We're going to solve for the value of x that will satisfy this equation. The given equation is 5 raised to the power of x is equal to 80. To solve for the value of x, the first thing we're going to observe is the base. If you look at the left hand side of this equation, the base is 5 and the right hand side we have 80. So there's no way we can balance the base. So therefore, we're going to take the log of both sides to the base of 10. So when we apply logarithm, we're going to take the log of 5 raised to the power of x, which is equal to log of 80. So the next thing we're going to do is to recall power property of logarithm. We say that when you have a term raised to the power, so the power is going to go back to multiply the log. So when we apply that property, this log 5 raised to the power of x is going to be what? X multiplied by log of 5, which is going to be equal to log of 80. The next thing we're going to do, remember we're looking for the value of x, and here we have log 5 attached to x. So we're going to divide both sides by log of 5. So we divide the left hand side by log of 5 and also the right hand side by log of 5. So that this log 5 is going to cancel this log 5. In the left hand side we are left with only x, which is equal to log of 80 then over log of 5. But we're not going to stop at here. We're going to simplify the right hand side to its lowest form. So we're going to have x to be equal to log of 80 can also be written as what? 5 multiplied by 16, which is the same as 80. Then everything all over log of 5. Now from here, we're going to recall one of the property of logarithm. We see that when we have log of a multiplied by b, this is the same as what? Log of a then plus log of b. So if you look at here, it's in form of this numerator. So we're going to transform into this form where a represents 5 and b represents 16. So when we do that, we're going to have x to be equal to log of 5 then plus log of 16. So we have already transformed this numerator from this form to this form. So everything all over log of 5. So the next thing we're going to recall is this basic law of mathematics. We say if we have a plus b over c, this is the same as what? A over c then plus b over c. So what does that mean? It means that this denominator that is only one term, log 5, the two numerator can share this denominator. So when we do that, we're going to have x to be equal to log of 5 divided by log of 5 then plus log of 16 divided by log of 5. So as you can see, this one term in the denominator, the two numerator share the same denominator. So the next thing we're going to do is to simplify the right hand side further. We're going to have x to be equal to log 5 divided by log 5. The same thing divide itself is going to be equal to 1 then plus log of 16 is the same as 2 raised to the power of 4, because when you multiply 2 by 2 in 4 places, it's going to give us 16, then everything all over log of 5. Now we're going to have x to be equal to 1 plus log of 2 raised to the power of 4 over log 5. This power 4 here is going to go back to multiply the log. So we're going to have 1 plus 4 log 2 then over log of 5. So the next we're going to do is to factor out this 4. Then we apply what we call changing of base property to this log 2 over log 5. So this is going to be what? X to be equal to what? 1 plus, so this 4 we're going to factor it out, then multiply by log 2 over log 5. So from here we're going to record this property that say when we have log of a over log of b, this is the same as what? Log a to the base of b. So as you can see, log 2 over log 5 is in form of this, then to transform into this form is going to be what? Log of 2 then to the base of 5. So here is the value of x that satisfy this exponential equation. Thank you for watching, and please don't forget to subscribe to this YouTube channel for more videos like this.